Nowadays, everything has to be lightweight. Your shoes feel like a feather. Your laptop is lighter than the wind. You must have an ultra-light bike frame to be fast. And of course, you want to cut down the weight of an exoskeleton. But why do we want that? And how can we drop a couple of kilos? We will tell you all about it in this video. There are a couple of reasons why we want an exoskeleton to be lightweight. First of all, by reducing the weight, the frame has to endure fewer forces and can therefore be a bit smaller. Also, the joints have to deliver less power to move the exoskeleton. Furthermore, it should be easier to walk with the exoskeleton since natural balance is less affected. As you might know, walking upright becomes a bit more difficult if you are wearing a heavy backpack. You have to lean forward all the time because you keep being pulled back. If an exoskeleton has a lot of weight on the wrong places, it can easily throw your pilot off balance. And, last but not least, a more lightweight and compact design makes it easier to handle when switched off. This might enable pilots in the future to carry their own exoskeleton. It could also contribute to a sleek design that can be worn whilst being seated in a wheelchair, or that could be worn underneath clothing. There are two main methods to reduce weight in the design: choosing the right materials and optimizing structure. Commonly used materials in exoskeletons are aluminium, steel, and carbon fiber. Aluminium is a relatively lightweight metal that is easy to work with. Manufacturing aluminium parts is low in cost, and combined with reasonable material properties, it is very popular. For example, aluminium is often used for soda cans, but also for manufacturing the frame of an exoskeleton. It has to be strong, but since these parts are quite big, you don't want to use a very heavy material. Steel is stronger than aluminium, but more expensive, very heavy, and much harder to manipulate. It can be useful for small parts that need to be very strong and do not contain complicated shapes. Carbon fiber is an emerging star in the world of manufacturing. Long strings of carbon atoms are bound together to form strands of fibers. These fibers are woven to create fabric. Often, multiple layers of this fabric are bound together using resin, creating a composite material. This carbon fiber composite is known to be very strong and lightweight, but can be quite complicated to manufacture. Carbon fiber can be used as an alternative for aluminium if properly layered and shaped. I've just talked about properties such as strength and weight. Other important factors are elasticity and brittleness. If a material is quite elastic, it can deform quite easily under pressure. These deformations might not be desired. If, for example, an exoskeleton bone would be too elastic, it might bend too much and break the pilot's leg. If a material is stiff, it will not deform a lot when forces are applied. This sounds really good, but a very stiff material is often also quite brittle. A brittle material has little deformation before it snaps. Imagine a piece of bread. When you try to bend it, it will deform and slowly start to break apart. A biscuit, on the other hand, won't really deform, but just suddenly snap at some point. A very brittle material can be very strong, but can absorb little energy before it breaks. Depending on the use of the material within an exoskeleton, a trade-off has to be made in strength, weight, brittleness, and cost. If you have made a choice on what material you are going to use for your part, the next thing you can think about is structure. When designing a part, you have to assess the forces that will be applied. Sometimes you only need to withstand forces in a certain direction. You can alter your design so that it's only very strong in that specific direction. Imagine, for example, a straw. You could say that a straw isn't very strong, but if you put your fingers on the top and bottom, you can squeeze with quite some strength without deformation. If you would fill this straw with plastic, it wouldn't get much stronger in that direction, but you would increase the weight a lot. Of course, it would become stronger in the other directions. Key is to determine in which directions you actually need to be able to withstand the forces. Removing material where you don't need it can greatly impact the weight of a part. Choosing the right materials and optimizing your design is essential if you want to build a strong, lightweight exoskeleton. It might sound quite easy, but it requires a lot of knowledge on the magnitude and directions of forces in the exoskeleton. Testing with different combinations can help a lot in getting to know your options. Later on, in the reading on different March exoskeletons, we will compare the frame designs. There, you will see that for the past few years, we have stuck mainly to aluminium frames and experimented quite a lot with how to shape them. You will also see that we use a lot of 3D printed materials for non-bearing parts. We will get into the plastic covered plates on our exoskeleton at the end of this week.